By now you should be very familiar with the Pythagorean theorem. The Pythagorean theorem applies to right triangles, and it states that the sum of the squares of the two legs of the right triangle is equal to the square of the hypotenuse. Now we'll solve some word problems using the Pythagorean theorem. Drawing a picture is helpful with these problems. We're going to draw a square, which means all of the sides are congruent and all of the angles are right angles or 90 degrees, and it has a diagonal with length of 20 centimeters. Our goal is to find the measure of each side. We want to use the Pythagorean theorem to solve this problem. Because it's a square, the lengths of all of the sides are equal. So we'll let b equal a, and we'll substitute a in the place of b into the Pythagorean theorem. Then we'll combine like terms and substitute 20 for c. After that, divide by 2 and take the square root of both sides to solve. For the next example, we're looking for the length of an altitude of an equilateral triangle. We'll draw a triangle with congruent sides, and the side length given is 12. An altitude is a line segment that is perpendicular to one side of a triangle and passes through the opposite vertex of the triangle. In an equilateral triangle, an altitude bisects the base. Using the right triangle we've created with the altitude and half of the base, we can solve using the Pythagorean theorem for the altitude length. For this next problem, I'm going to use graph paper to plot the distance that Jalen and Kyle travel as they move toward Harrison High School. I've plotted Harrison High School at the center of my coordinate plane. It says Jalen travels 2 miles east and then 4 miles south to get to Harrison High School. I'm going to reverse his path, moving west 2 and north 4 to plot his starting coordinates. I'll do the same for Kyle. He traveled 3 miles west and 5 miles north. I'll reverse his path, going 3 miles to the east and 5 miles to the south to plot his original coordinates. Next, I'll create a right triangle, and the hypotenuse will represent the distance between the 2 points. You could also use the distance formula to calculate the distance between them. I'm going to use the Pythagorean theorem, counting the length of each leg and substituting those values into the formula. Again, we could have used the distance formula to find the distance between these 2 points, so I'll demonstrate that now. This is handier when the distance between the points is greater, or when you are not given a graph, or the graph would have to be really big when you sketch it out. This way, it makes it harder to count the lengths of the sides and easier to just substitute the coordinates into the formula and solve.